Hello friends, family, but most likely Mr. Bacchi. Today, I'll be telling you about my household water usage story. My name is Lex Whitehead. I am in period 3. I believe that the population of a residential place is the deciding factor in the amount of water used, which means that I think that the more people, the more water will be used. And you'll see why. I got my data through a class survey where everyone calculated roughly the water they use in their household. The city data came from the 2010 census. But the Roseville population is from 2021. The purpose of this project is to see if water usage is affected by more than just the population number, and if Roseville is good at balancing its water usage. Okay, so as you can see here, I calculated my line of best fit, which shows that the more people that live in the house, the higher the water usage. People in 4-person households tend to use the same amount of water as a 7-person household, as you can see by the fact there's like a straight line going across the two of them. The slope for my line is y equals 116x plus 0. I chose this slope for my line of best fit because it goes in between majority of the points evenly, and I chose the y-intercept of 0 because if you have 0 people in a house, you cannot use water because ghosts don't know how to turn on the tap or start a shower or put in a load of laundry. So my house, in comparison to the rest of the houses, was below the least square regression line model, meaning I used less water than average out of this data set, which I'm pretty proud of if I do say so myself. My line compared to the LSRL is a bit lower, and the LSRL doesn't start at 0, which I don't understand because how can you use water if there's no people in the house? What's going on there? The R squared is 0.15, which in this case is a bad line of best fit because a 0.35 is the minimum to be a good one. This means that there is too much diversity in water use, and everyone needs to tone it down. My water usage claims are that it is likely that the more water used in a house, the more people live in it. This can be seen through the gradual increase throughout the line of best fit. Some confounding variables could be income, because maybe like more money you get, the more you can spend on water. If you have a pool, because that needs to be refilled, cleaned. Pools get real gross. Kids, because kids get real gross and you need to throw them in the bath sometimes. If you have no dishwasher, because hand washing takes more water, or a dirtier occupation, because I know that when my dad worked for pest control, he was throwing in loads of laundry left and right like there was no tomorrow. As you can see here, I have some graphs. I will now explain to you what these graphs mean. So the one on the very left is population versus water usage, with population on the x-axis and water usage on the y-axis, with an r squared of 0.658, which that's a really good r squared. And then we can see the two variables that I tested out on the side, which was water coverage versus water use, with water coverage on the bottom, water use on the y, which had a very bad r squared of 0.1. And then we have our other one of total rainfall versus water use with the r squared, yet again, of 0.1. And I think all in all this just means that I came up with bad variables. So my updated water usage claims is that I believe that it is population that determines water usage, because when referring back to my attempts to find a confounding variable, you can see that all of it was very, very wrong. Population also has the highest r squared value, higher than that which is needed to have a strong correlation. Previously, I believed that water coverage and rainfall could have a greater impact on the amount of water used, but through my very scientific research and graphing, I have discovered that I was in fact wrong, and population is the only correct answer out of the data that I have seen in my science journeys. So next, we have Roseville water usage, where I used very scientific math to figure out how things go in Roseville. For daily water usage, I found out that it was 96 million something gallons. I found this using the LSRL equation on population v water use, and it's y equals 133x plus 76,000 something. And I inserted the Roseville population as x and found y for weekly water use. It's 675 million something gallons, and I just multiplied the daily by 7 because that's how many days are in a week. The monthly water usage is 2 billion something gallons, which I just multiplied weekly by 4 because on average there's 4 weeks in a month. And then for yearly, I multiplied the daily by 365 because that's how many days are in a year. And I got 35 billion? 35 billion. Yeah, 35 billion. Next up, you can see the Roseville water usage versus everywhere else water usage. Roseville is very average at the water usage because it's right along the line of best fit compared to all the other cities. I think that my plot would be great to use for the state because if Roseville's in the middle, I trust it because I think that Roseville's kind of mediocre, but this shouldn't be about my personal opinions. My bad. Sorry, Mr. Bacchi. I think using my various plots and graphs and surprises in the corner that I could not find big houses in schools because that would be too hard. And too much water. Especially at schools because kids are stupid and I see them leave the tap on in science classrooms and I watch them clog toilets with 4 million paper towels or whatever the fuck is in there. Oh, sorry. Yeah. Adios.